Okay, good afternoon. It's nice to be back. So first of all, an announcement. So the lunch will be today at 12:30 instead of 1 o'clock. So 12:30, yes, and for half an hour. So please try to be back at 1. So the lunch will be at 12:20. Usually it's at 12. Sorry, at 12, but now it's at 12:30, and for half an hour only, because of some other events that take place now in parallel here at TTU. So there is this change. So please try to make it in half an hour. So this means that I'm going to talk here and interact with you for a bit over 1 hour, so one hour and 15 minutes or so. So that presentation by Microsoft was a good one, wasn't it? So I really enjoyed it, and a couple of things that I picked out. The first thing was simplicity. Keep it simple. And as you may remember, I have emphasized it several times that one of the main advantages of agent-oriented models is simplicity. And this is particularly true for analysis models, for models that we have addressed so far. So I mean goal models, role models, organization model, and domain model. So the second message was that view an overall picture. So don't focus on technology. Don't think about web application or service only, but think about a broad picture that includes stakeholders, that includes a social reality, not just your narrow application, which just forms a part of your system. So try to approach your product idea in a systematic way, viewing it as a socio-technical system is the proper word, I think. And this is exactly the reason why we model roles here, and why we model relationships between roles. And this is also the reason why I do not really tolerate the role user, because it is too narrow. It is just focuses on that particular application or web service or platform, but that is not enough in the contemporary world. So we need always to focus on a larger picture. I mean, you do not sell a product now. It's not possible to sell any product by just focusing on that application alone, by just focusing on that technological solution. But all products these days are social. The third thing I would like to emphasize is this concerns Friday. So on Friday afternoon, you will have an opportunity to present your product ideas in front of venture capitalists. So there will be venture capitalists and some other people here, including myself, I think, judging your ideas. And in those presentations, there should be something from each course that you have attended. And now, my proposal to you is, let us try to impress venture capitalists with a nice goal model, because this is the only thing we can do properly. You have only 20 seconds for this course, as I understood from Alar. So this means that you have only 20 seconds to present your product model. So how do you see your product functioning? What is the purpose of your product, and what are its sub-goals? And I think a goal model is a very nice way to explain it in a simple and short, efficient way, because it contains the overall picture. it summarizes the most important things about your product, which is the purpose, the different functionalities, and also the roles that are required for achieving this, the purpose, and for performing the functionalities that are represented as sub-goals. There are many more models that we have already addressed and that we will address today and on Thursday and Friday, because I'm trying to give you an overall picture. I think you won't be very happy if I would confine this course just to goal models and that's it. I mean you would be rather disappointed, especially those of you who are more technically inclined. So that's why I am talking about other kinds of models. But for Friday, please try to come up with as good goal models as possible. And of course, I am here to help you with that. And there will be more time on Friday when you can then elaborate your different models, business model, other kind of stuff that you need for your presentation, but also the goal model. So all in all, you will have 2 minutes. Each team will have 2 minutes, and 20 seconds of that then will be a presentation of the goal model. Now, just before we start, to sum up what we have learned so far, my original plan was to use a whiteboard or that device, but I don't dare really use that one, even though it is in principle it is a whiteboard, but okay, let's leave it as it is. So it wasn't hard. For some reason it was hard to find a whiteboard in summertime here, because simply there was no whiteboards available. But okay, I will do it just by words and gestures. So what we have been doing so far. So we have modeled an answer to the what question. So what is the purpose of your product, and what sub-goals does your product need to achieve? I mean, sub-goals under the purpose. So this, the hierarchical goal model constitutes an answer to the what question. So what goals does your product need to achieve in order to be really valuable for someone? The second question is who are going to achieve it? And we represent an answer to the who question through roles. So that's why we attach roles to goals. And as you remember, whenever I attach a role to a goal, then that role is relevant not to just that particular goal, but also to all its sub-goals. So the roles, they provide us with an answer to the who question. Then it is also important to explicitly capture the relationships between the roles, because we talk about organizations, we talk about social reality that our applications address and that they are intertwined with. So again, I repeated that it's not just about the technology, but it is about a social system intertwined with technology, and they all together make up a socio-technical system. And then the third thing, we also need to capture the knowledge that the roles need to achieve the goals set for the system. And that is what we use domain models for. By domain models, we represent the knowledge that is required by goals to achieve, that is required by roles to achieve the goals set for the system. So that is the meaning and importance of domain models. And this is how the models of the analysis stage come together. So was this clear, or are there any questions about this part? So, and the main thing about analysis models is simplicity. And I hope that I have managed to convey that message that analysis models are really simple. And according to what I have seen so far, you're working on goal models, role models, organization model, also domain model. I think that you have managed very well, which is a kind of proof that they are really simple. Of course, it's with every new thing. I mean, there is some learning curve here, and this is normal. I mean, it's not that there cannot be a thing. I mean, where there is no learning curve at all. But I think the learning curve is somewhat lower here compared to some other methodologies that are used for designing software systems, including the UML language. Yes?
Where is this curve that goes from UML diagram to actual implementation? When we stop, so-called? When should we stop?
Yes, so this I will actually continue today about that. So because today we are actually getting more technical here, but I hope not too technical, because not all of you have a background in software engineering or in technology, but still more technical. And I would like to end up with at least talking about prototypes. And a prototype is an implementation. It is not a real system, but it is a kind of simulation or a kind of mirror of a real system. And the prototyping is actually a very important phase in developing your product idea. And you mentioned the Garage 48. I think actually what they implement there are prototypes, not full products, but prototypes to the extent that they can be demonstrated to venture capitalists. And the question that will be asked then is it, does it make sense? I mean, is this the product that you would be willing to fund in the future? So this is the question. So is that the prototype, does it represent something realistic from the perspective of a venture capitalist? So my goal here is to end up with at least talking about prototypes, and I will demonstrate some prototypes. I do not think we have time to do prototyping, so you can do it as a home exercise, but I do not think we have time to do it here. But I will give you some ideas. Now, concerning prototyping, the notion of agent here plays an important role, and I will come to that. So the notion of agent, I mean, why is it important, and why I emphasize it? There are different reasons for that. So one reason is that an agent is a powerful modeling notion. And another reason is that by using agents, like software agents, it is actually relatively easy and fast to implement prototypes. Why? Because by using software agents, and especially those that include some elements, some features of artificial intelligence, we can simulate humans or organizations that are not necessarily part of the service or of the prototype when you try it out in real life, because it's not easy to make experiments in a society. But by using this kind of approach, where software agents play the roles of some stakeholders in your system, we can end up with a full picture. So this is another reason. So first, agent as a powerful modeling abstraction, and second, with agents it is easier to end up with full-fledged prototypes that you could demonstrate to venture capitalists, for example. Now, little announcement here. So slides for today's lecture are available just at the same essentially at the same place as yesterday. So feel free to download them and follow what is going on. Okay, this I already covered. So now, as I said, we are becoming more technical here, and the first thing we need to do now is we need to start thinking about the boundary between a technical subsystem and a social subsystem. Or there may be several technical subsystems, several social subsystems. Well, as I said, in agent-oriented modeling, we postpone designing the boundary, because we do not deliberately, we do not decide it at the beginning, because this restricts, limits our ability to think creatively, to think in an innovative way about our product. But at some stage, we should decide the boundary. And one option is to do it here when we start thinking about the pieces of software that should be included by our system. And here is an example, again this example of Tamagotchis here, and I think this boundary is obvious here, isn't it? The boundary between social subsystem and between a technical subsystem. Yep, exactly. So it's here. The owner on one side and my Tamagotchi on the other side. And this is also actually friend Tamagotchi is played by another Tamagotchi, and another, I mean this digital pet Tamagotchi. So this is also forms a part of the technical subsystem. Of course, the other Tamagotchi also has the owner, so there is another boundary here, but for the sake of simplicity, we do not address it here, because there is no difference from this boundary. In the other case study, the case study of grocery shopping, well, it is also pretty straightforward. So on one side, we have customers. Customers are peers to each other, as we talked yesterday. Then there are stores. A store is benevolent to a customer. And then on the other side is the assistant. And assistant, in our case, is played by some software entity, by some piece of code, and we call it an agent. And there is also the coordinator, and coordinator role is played also by some software entity. And there is peer-to relationship between them. Of course, we could do it in different ways. I mean, this is not the only possible architecture. For example, we could omit the coordinator altogether. So we could have a fully peer-to-peer, fully decentralized solution. But in this case, we have chosen the coordinator. So, well, I could talk a lot about it. I mean, why have we made this kind of decision? But I don't think it's so relevant here to spend too much time about it. But what I will talk about soon, I will talk about different possible architectural solutions. So as I said, we now need to decide the types of components, agents of the socio-technical system. And the term agent here subsumes both human agents and the so-called man-made or artificial agents, like software agents. So why agents? I already addressed it. So because it is a powerful modeling notion on one hand, and because it enables us to reach fast prototypes, or rapid prototypes in a very fast manner. one of the most important features why I claim that an agent is a powerful modeling notion is its proactivity. I mean, because you know, when you talk about services, well, the service is by definition reactive. The service waits for a query or waits for a request and then receives it, processes it, and then replies. But there is no notion of proactivity in service by definition. Of course, you can build more proactive services, but it's still a kind of add-on. This notion of proactivity doesn't naturally belong to how we understand services. So proactivity is very important. It is not included by service, the notion of service, and this is why we do not use the modeling concept of service here, but we use the concept of agent instead. And now let's do a little exercise together to make it all more lively. Let's take all these 8, I believe, product ideas that you have, and let's go them through one by one, and let's try to analyze if and where the feature of proactivity is required in those case studies, in those product ideas. And now let's take this case study. So manufacturing down there. So do you think that proactivity is needed in your system, or do you think that there is a need for a proactive component in your system, and what it would be if it is needed?
If I understand it correctly, then our system needs proactivity because if they talk about to use the user word, but the user of the platform intermediator, intermediator gets points for several things that does in the system. So the system has to understand that give points for these actions. I don't know, is this proactivity or not?
You mean the intermediator, the user, yes. I mean, performs some actions, yes. And then the system takes note of these actions, and then the system should actually reason about these actions and then give some points. Yes. So it's not an immediate reaction, but it is following trends and deciding based on those trends. So is this? I mean trend. I mean like trends of actions by intermediator. Or is this what you meant?
Yes, kind of. If I understand proactivity correctly.
So the points are not. Is it so that the points are given right away?
Yes. Yes, the points should be given right away.
So then it's probably based on some event right away, or can there be something that is based on reasoning and thinking about the user's behavior in a longer time frame? Yeah, I think would be quite reasonable there actually, to not just the immediate activities, but just to see how the user has behaved within a longer time frame, and then assigning points accordingly. Yeah. Okay. Good. Thank you. Okay. So smart insurance. It's a small team here.
I think it's pretty much the same. The principle that to monitor the users or drivers' actions, and reason these actions and analyze.
Yeah. Yes. Yes. So exactly, and this means that that agent, let's call it this way, who does it, then just collects information, analyzes that information, and then at some stage makes conclusions. But it doesn't happen right at that time when it perceives some behavior by the driver, but it happens later on.
Yes, I think there are some So if it's in this way, you can't interact with the driver while driving because you would be
exactly.
risk source.
And you need to analyze the behavior of the driver within the longer time frame in order to make correct conclusions. Yes? Yep, exactly. Then co-eat. Please come in random order.
For our system, it needs to know what the local food providers are providing so that consumers can decide what they want from it. And also there's the other part that we need to know who are the people who are creating events. We need to have the feedback and the trustometer, how trustworthy the persons are.
Yes.
That's correct.
Trustworthiness. One thing is maybe gathering the information about what is going on and then judging about the trustworthiness of food providers, I assume.
Yeah, and also the consumers.
But also about
the event planners.
The event planners, yes. And so another thing probably can be gathering information about habits by people. And creating their profiles. Of course, and if they are happy with it, I mean, we should always ask for consent here. Yes. And then based on then recommending events based on their profiles.
Yes.
Yes. So that
preferences are.
Yeah, preferences. Yeah. Yeah. So again, it's not immediate. It's not based on some event. I mean, it's not based on something that agent perceives that a customer wants this or that, but it may be a proactive recommendation that there is that kind of event going on, and that I think it would be appropriate for you. Yes, good, thank you. Then a smart house.
We are arguing about. Actually, we consider users as an agent. I mean, every user, you don't like this word. I mean, the role, yes. Every role is actually active role. Yes. I mean, turning on the television is a proactive action. Television doesn't turn itself. Yes. But also, if we consider the artificial entities, yeah. we also need the agents to monitor our technological systems like water pumps, the heating system, because heating system can issue the events by itself when something is happening. But from the other side, we can use agent that does it without events. So acquires, for example, periodically the temperature sensor. So yeah, two approaches is possible. But yeah, first is actually managing the technical devices.
Actually, it is perfectly all right to talk about users or I mean, people playing different roles as proactive entities here. But also these software agents, for example, that could accumulate data about devices and about interactions between these devices and interactions between devices and humans, and then would conclude something based on that data, so they are definitely proactive. Yes? Yes? Good. Thank you. Life in you.
Yeah, so as agents, we might have pregnant women themselves, which we monitor, and also we might have the system, the monitoring system, because there is where we store every information, we measure them, so we provide after that information. So as Smart House said before, we might have two agents, the woman and the technology.
Yes. Yes, and regarding the technology, I think it is very important here to monitor, follow trends, because some conditions can be discovered only by following trends rather than by single events. In medicine, it is very relevant to see the overall picture. and smash. So it's here. Discussing. Would you need more time? Or? Need more time? Okay. Cloud by. Or where was it?
Some new one.
Was there the group of cloud by? Or no? Or food basket?
Here.
Yep.
So from agent side, it's again our customers, restaurants. Our customers want to order the food, restaurants want to deliver food, update menus. And from process, it's the same search, find, choose process because it's based on our main goal and it's based on our data about reviews and about this food database. And of course, for restaurants, it's data about customers. Again, it's based on our database, our customers' database.
So then you are talking about recommendations.
Yes,
recommendations.
Mainly grading system, like
Grading system.
like how fast is delivery, how tasty your
like
food.
price and so on. So
Yes, yes. So grading, evaluating, so that other customers could actually benefit from this. Yes. Yes, this is a very important point. So I think two things there: grading and also profiling. I mean, giving recommendations that taking your profile, I would recommend you to go to that restaurant or order food from that restaurant.
Same as location based too, because we know that you're okay in Tallinn, so we recommend you to go order some from Tallinn's restaurant.
Yes. And it can include the location of the tourist, for example.
Yeah.
And also if his or her profile is known, then the profile. And it also includes the feedback by other customers.
Yes.
By the way, when it comes to the feedback by customers, then well, we all do it. I mean, we all use social networking services like Facebook in the first place, but also some others, Twitter, for giving feedback. But according to my understanding, this is still pretty manual. Everyone comments something, everyone discusses something, but there is no way to easily obtain an overall picture. And this is why I think that software agents could help here. If I would have an agent that would process information about feedback concerning, for example, places where I could order food from, then my life would become much easier. So I think we are still halfway in automation here. I mean, a lot more could be automated in social networking, but these social networking services we have today, they are manual, I would call them this way, rather than automated social networking services. Do you agree?
Yes, and I was making the research in marketing, and I was talking in our local, about our local social network. They have this like algorithm that they are using for some companies. If you need some data, okay, you can get this data, but of course not for end users. Yeah.
Yes, yes. But if someone of you would come up with a system that enables end users to both provide data and also process data under their control, rather than under the control of Facebook, for example. And then, in such a case, these end users could also benefit from the data, because it is all, I mean, this whole system will function in the interests of those end users. Okay, so are there any groups I didn't cover? Because the structure of groups has changed here, and maybe not all groups are were included here in my list?
The word included is yes.
Okay, we haven't been covered because we did not have an answer when you had asked us. So I think productivity of our system is we have like agents, customer, and friend. And from the point of view of friend, as customers invites him or her for interaction, and actually this moment is productivity. Also, we see as a productive elements that you could see in our system your friends are mobile at this moment, so you could interact with them or ask questions from them. Additionally, we have a social reward system as well that it invites you for achieving some new level, let's say, for example, to interact with your friends a little more, answer a little more questions.
So then the participants in the system, they are rewarded with some points.
Yes,
based on
some
their
points, levels, yes, some maybe nice things.
And this is based on their activities
Yes.
In the system, and then that information is used later on.
Yes, for some evaluation, for also showing them maybe before hours and so on.
So, have you considered any recommendations by the system? Does it recommend users?
We have considered it, but let's say at the moment it's not yet there. We decided to keep it, let's say, simple.
Yes.
One of the recommendations where we see would be that one of our possibilities will be to join some people to the groups. That, for example, that I'm asking for opinion from, let's say, hippie groups or from groups who likes, let's say, fast cars or something like that. And then it would give you some recommendation to join this group, for example.
Yes, so this is definitely proactive behavior.
Yeah.
Because you collect these recommendations and then, well, I mean not you, but software agent, for example, collects recommendations, analyzes them, and then helps a customer in decision making.
Yeah.
So, have I covered all the groups? Okay. So, one more note about proactivity is that, in my view, if you really want to impress venture capitalists or anyone, then I would recommend to include some proactive features in your system. Because, I mean, we have too many reactive systems around already, but not so many proactive systems. So that's why the proactivity is enormously important, because it at least gives an impression of your system being intelligent. Well, my system, I mean, that proactively recommends me to do something, or based on the knowledge that it has gathered. So much in the same way as my Tamagotchi proactively asks for food and proactively asks for fellowship and asks for entertainment. So proactivity is very important in really innovative products. Now, how do we map roles to the types of agents? And now when I'm talking about the types of agents, again, I include both the human agents and man-made agents. So there are some principles that can be followed here. So the first, or actually there are two groups of principles. So the first group is related or give hints about decisions where several roles are mapped to one agent type. So when several roles are mapped to one agent type, then as some hints or just as some directions, one of the following conditions might be true. But these are not absolute guidelines. I mean, it is not law, but they are just hints or just they are meant just to help modelers. So the first hint here is that several roles are mapped to one agent type when roles are closely related. They naturally belong together, meaning that there is a high cohesion between these roles. And an example here is the cohesion between delivery unit and transport unit in some system of electronic commerce, like some of the one system here at least is in that area. So when there is a high cohesion between delivery unit and transport unit, then it may make sense to just choose one agent to represent both units. But it's not necessarily. It all depends on the situation, because in some cases transportation is done by other companies. The transportation is outsourced. And of course, in such a case when transportation outsourced, there is no point in mapping these roles of delivery unit and transport unit to one software entity. So it all depends. So the next hint is, if two roles use the same data or knowledge, that is represented by domain model that I introduced yesterday. So if two roles use the same knowledge, and especially if both update or produce the knowledge, then it might be reasonable to map those roles to one agent type. So I think this is pretty straightforward. If two roles produce or use the same knowledge, then it might be reasonable to map them to one agent type. And the third is if two roles interact a lot, or of course we haven't modeled interactions yet, but we have organization model. And the by organization model we can also judge if if these roles, or if to be now precise, if agents playing those roles, they are to interact a lot. Then in such a case we might think about mapping these roles to one agent type. But here there is a note that this is a weaker kind of coupling, meaning that the very fact that two roles interact, or agents playing two roles interact a lot, doesn't necessarily mean that these roles have to be mapped to one agent type, because interaction is a natural concept in agent-oriented modeling. So it in many cases it is perfectly all right to just have this to just map these roles to different agents and then model and implement interactions between these agents. So this is then the situation where several roles are mapped to one agent type. And of course what I'm talking here is particularly related to software agents. So this is more about software, but it also, in the same way, it also applies to humans, the so-called human agents. So the second situation is where one role is mapped to one agent type. And a couple of hints in the direction when this could be feasible are the following ones. The first hint is that if two roles are unrelated, then we should map them each role to a different agent type, because otherwise we will end up with a non-cohesive agent. If we map a totally different roles, like for example a customer and administrator to one agent type, then this will result in a mess, will result in a totally non-cohesive agent that is hard to maintain, that is hard to understand, that is hard to use. And the second hint is here for this situation where one role is mapped to one agent type is when roles need to reside on different hardware platforms. And here I mentioned already technology. I mentioned hardware platforms. Usually we have avoided the technology-related terms so far, but here it is necessary, because if it can be foreseen that the agents playing the two roles need to reside on different hardware platforms, there is absolutely no point to map these roles to one agent type. But each of these roles should be mapped to different agent types. So these are some criteria for deciding agent types. So was this understandable, or are there any questions? And of course, agents, they do not need to be software agents in the strict sense. Of course, I as an agent researcher, I promote software agents, I like them, I think they could be useful, they could improve our quality of life, they could be applied in innovative products, but we can also actually talk about software components, and particularly if proactivity is not required, then we can just talk about some services. But at least at the implementation level. But still, as the concept of agent entails both reactivity and proactivity, I still would recommend to use that concept, at least here in modeling, in designing your product. So now we are back to the viewpoint framework, and the next type of model we need to cover is agent model. And agent model is the model that represents mapping from roles to types of agents. I emphasize the types of agents because this is what we decide. Not individual agents, which are instances of those types, but just types of agents. And as I said, the purpose of agent models is to transform the abstract constructs from the analysis stage, roles, to design constructs, agent types, that are more concrete because they will be realized at runtime in one way or another, in the form of a software agent, in the form of a service, some other form, but they will be realized. And in general, there are many relationships between roles and agent types. And I already described some criteria for mapping roles to agent types. So in general, it is many to many, meaning that one role can be mapped to several agent types, or several roles can be mapped to one agent type. And here is an example of agent model. I am not going to actually ask you to create such models. I'm going to ask you to show the possible mapping from roles to agent types, but there is no need to create tables of this kind. But basically they represent, just like role models, the name of it, the agent type, short description, then the roles from which this agent type has been mapped. Like here, my Tamagotchi and friend Tamagotchi are mapped to the agent type Tamagotchi, and this is a software agent type here, or digital agent type, because as I said, the Tamagotchi is the creature that lives in the box. It's not the box itself, but someone who lives inside. And some environmental considerations like Tamagotchi shell and Tamagotchi town, just mentioned here, that these are the environments where these agent types, where agents of this type occur. Then for this shopping case study, the same thing. Agent type name is ShopBot. Description, the type of a software agent assisting a customer with grocery shopping. The role is assistant. Remember, there was the assistant role, and that was mapped to the agent type ShopBot. And environmental considerations, perhaps Facebook is the environment where agents of this type can be embedded. So why not? It could be actually linked to Facebook. Okay, so that was about agent models. So now you don't need to create tables of this kind, but you just need to decide the mapping. And now about acquaintance models. So acquaintance models, they answer the question, who is whose friend, or who goes with whom. So this is the question here. So acquaintance model identifies, represents interaction pathways between agent types. So, as I said, the acquaintance model outlines interaction pathways between the agents of the socio-technical system, including human agents. And here is an example. For Tamagotchi, this is the agent type Tamagotchi, the agent type person. This can be that simple. Of course, we can have more specific names also for agent types, like we have for roles. But here it is just a person. Then there is acquaintance between Tamagotchi and person, and one here means that one person can interact with one Tamagotchi at the same time. And then this lower part here is mappings from roles to agent types. So the roles my Tamagotchi and friend Tamagotchi are mapped to the agent type Tamagotchi, and the roles owner and the owner of friend Tamagotchi are mapped to person. And the acquaintance model for grocery shopping, it doesn't show that mapping from roles to agent types, but just acquaintances. So it shows that there is the agent type shopbot, then shopbots interact with each other. Several M and M means that one shopbot can interact with many other shopbots, and the other way around. There is the coordinator agent. M and 1 means here that there is just one coordinator agent who interacts with several shopbots, each representing a shopper, a customer. And then there is a human agent, and there is one shopbot corresponding to one human agent. And this is a notation I sometimes use for agent types. But here, feel free about notation here. Use whatever notation you prefer, either this kind of notation, which is the simplest, or if you wish, also notation like shown here. And now, here is appropriate to make some notes about the architecture of the system. And this is now becoming even more technical. Because when we decide acquaintances between agents, or between software components, and of course also between software components and humans, then we are essentially deciding the architecture of the system. And now it's very important to actually bear on mind different possible architectural styles. And the kind of two fundamental styles are client-server style and peer-to-peer style. So a client-server, I think everyone knows about it. It's a very usual, the most widespread style. When there is a client, and the client queries, waits, queries for something, waits for reply, and then receives answer, and server waits, serves the queries, but doesn't query as a rule itself. So this is a client-server system where, if you wish, the roles have been clearly distinguished here. There is the role of a client who is active, queries, waits, receives, and there is the role of kind of passive server who just waits, serves queries, but doesn't query. In other words, server doesn't have proactive behavior as a rule. Of course, those who are more technically inclined here know that there can be more proactive kinds of servers, but I don't think we need to go to technical details here. So this is the principle. And another style is peer-to-peer. And peer-to-peer is not just science fiction or something that just is used in gaming, for example. But, so what is the most well-known peer-to-peer system? Torrent, yes. Anything else? Skype, yes? Skype is based on peer-to-peer principles. Because this is the very business idea of Skype, actually. This is the core of their business idea. They do not want servers. They just make use of the existing network, make use of the existing nodes. They just direct their traffic through existing nodes, and each laptop here can be one of such nodes, for example. At least each computer that is connected to a public network, and here you are connected to a public TTO network. So you can right now a lot of traffic of Skype can actually go through your laptops here. Of course, you can. Well, those who are more technically inclined, you can actually block it out. There is an option for that. But basically, this is the core of the business idea of Skype, as you may have read from the nice book by Osterwalder, or maybe someone told you about it here as well. But if not, then tomorrow there will be a presentation by Skype that I'm very much looking forward to. In peer-to-peer, all nodes are equal. Each node can work as a client or as a server. There is no distinguishing between the roles here, and each node can offer different resources like computing, memory, bandwidth, information resources. In the case of Skype, each node, like each laptop here, not each, but many, they offer bandwidth resources for forwarding the traffic, for forwarding Skype calls or Skype instant messages. And then it is a kind of a comparison between client server and peer-to-peer. There are pros and cons for each. Peer-to-peer resources are distributed, which is a kind of safer. Maybe because it's not, you do not put all your eggs in one basket, as the saying goes. Peer-to-peer is more robust because it's distributed. It doesn't rely on just one centralized server, one centralized point of access. Peer-to-peer is more secure for the same reason. It is distributed. If one node fails, if several nodes fail, nothing happens. But of course, if a critical number of nodes fail, then bad things start to happen, as has happened to Skype a couple of times. The Skype has been down because the critical number of nodes failed. Peer-to-peer is trickier to test, of course. Peer-to-peer systems, including multi-agent systems, are much harder to test because they are distributed, and there is no centralized technological item that you can test, but you have to test the system as a whole. They are trickier to manage exactly for the same reason. I mean, you do not have an overall picture of the system. And this is, as far as I'm concerned, this is actually one of the biggest challenges by Skype. So they're trying to explore different data mining algorithms, for example, to understand the behavior of their own network that they have created. Because in such large systems like Skype, what happens is that the emergent behavior will occur. And emergent behavior is unexpected behavior that doesn't depend on just one node, one agent in the system. That it is not pre-programmed, but it is somehow emerges through interactions between those nodes. And actually, Skype faces this problem, and that's why they're trying to employ different data mining algorithms in order to understand their own network, in order to understand, how it evolves, in order to understand the behaviors of customers, and for example, when those customers who have left Skype, how to get them back and things like that. So it's a very actually complicated system that requires a totally different approach to maintenance compared to client-server systems. And as a rule, usually we have a hybrid networks, or not usually really, but it is very rare to find a full peer-to-peer system. Even Skype has some servers, and these servers they hold client data about the customers. So when you create a username in Skype, then it goes through server. Also, when you log in, it goes through server. So servers are needed even in peer-to-peer systems. So a typical layout is a peer-to-peer network and client-server directory. And some applications we went them through already. Are you aware of any peer-to-peer gaming applications? I think there are some gaming applications that are based on peer-to-peer principle. Yeah.
Gaming Steam, I heard about this.
Yes, I mean the games that do not rely on a central server, but there's just that are based on peer-to-peer principle. Yeah.
Steam can be considered.
Steam can be
You use
considered.
a central server to log in,
Okay.
but when
Yeah,
you create a game,
yes,
a local game, then it's only shared between or it's accessible only for the participants.
How is it called? Steam. Yes, this is what I mean. And of course, as I said, there is I mean, it's not even possible actually to have a 100% peer-to-peer, but it's still
Yes,
yes.
right.
But because for users, well, it's possible, but it's not feasible. Yes. Yeah. Okay. So at least found. Okay, I will add it. I mean later on, so that in my future presentations, I will have one example.
Also, PlayStation 3, there is in PlayStation 3 also there is a kind of peer-to-peer application. The players can play like online multiplayer with each other.
Yes.
So we can consider every PlayStation as also a node.
PlayStation 3. Yes,
PlayStation
another
3.
example. Okay, two examples already. Yes, and of course another interesting thing is that in some cases, centralized game, for example, a centralized application may have a peer-to-peer flavor, meaning that, well, it is actually there is a server, but the players, I mean, they get an impression of directly interacting with each other. So that is another phenomenon. And actually, well, that is fine, because, well, what matters is user experience by the, I mean, actual users of the system. And if they perceive it as peer-to-peer, even though in fact it is not, well, I mean, this is just a technological peculiarity here. I mean, it's not, conceptually we can regard it as peer-to-peer. So here, this slide is to show that there is no pure peer-to-peer systems, and especially when it comes to agents, then you see there are agents here. They are all individual or autonomous agents, all reactive, proactive, social, interact with each other, but they need services at a lower level. So because how else can two agents interact? I mean, they need some services at a lower level. There's services for actually passing their messages, for forwarding their messages in the network, because it's all it's all based on the internet infrastructure. And the internet infrastructure, I mean, there are different protocols, as you know, like SMTP, HTTP, and so on. And the same protocols are used for actually forwarding agent messages, for interactions between agents. So this means that if this agent is willing to interact with that one, then what happens really is that this agent calls some service, calls an interaction service, and this calls with certain parameters showing the destination of the message, the origin of the message, the content of the message, also the ontology of the message. The ontology is the semantic, joint semantic understanding for the message between sender and receiver. We're coming to ontologies. I think tomorrow when I will talk about knowledge models, because ontologies are about knowledge by agents. Well, each agent has a picture of the world, but if two agents want to interact, then they should have a joint picture understanding of the world. Otherwise, they are not able to interact. So this is about ontology, and referring to ontology is an important component of any agent message. So all this information, with all this information is service, interaction service. X is called, and then the agent C here, who is the receiver of the message, also has to call now and then the same service. Well, this is called polling. the agent now and then calls the service to see if it has got any new messages. And if there is a new message, then the agent retrieves the message and stores it in its buffer and then processes it at the time that the agent considers appropriate, as we discussed asynchronous communication a couple of days ago. So we need services, yeah, and we need also some even lower level functional objects that the services consist of. So it is all multi-layered system. So it's not just about the agents, but it's also about services, also about functional objects that services consist of. Yes?
Just when you start to describe this model, I remember one more game is actually can be considered quite as pure civilization when you play email mode. Like every single place, it's a turn-based strategy, and when you create the list of players, you must specify emails,
yes.
And to this list will be sent a message, yes. And everyone receives it, and the client uses it constantly. So you don't need to log in anywhere. You don't need to do any special. You don't need to use any special service. Yes. But the client receives emails and make a turn. And every
just based on emails.
Yeah, just based on emails.
I'm glad you brought it up actually, because email is a wonderful example of a peer-to-peer communication that is based on servers actually, in the sense that servers, well, like here, I mean, there are some servers here that I use, but basically you interact with each other in a peer-to-peer fashion. You just send a message to someone or many people, then it's called broadcast, but it is fully peer-to-peer. And actually one phenomenon that I do not fully understand is, for example, when it comes to searching for information, then it seems to me that many people, including myself, they actually prefer to store a lot of information in the form of old emails that they have received. I mean, well, you could always store it somewhere else, but somehow, I mean, there is an trend to keep it in emails, and then people usually they look for these emails if they need something. So, it's laziness on one hand, but on the other hand, it looks like the message-based approach is kind of natural to humans. That okay, when I have a problem, then I start thinking about the messages I have received about it. Maybe if I need some lecturer, well, as a professor, I use also external lecturers in my subject in software engineering, for example. Many people from industry come. So if I need a lecturer, then I start thinking about the emails that I have on store about the lecturers that have attended 1 year ago, for example. So it's kind of interesting. Okay, and basically, now we have come to teamwork, but well, I think let's do it this way, that we can have lunch pretty much now, like even 5 hours ahead, and I think then I will continue at 1, we will convene at 1, and I think I will then actually talk also about interaction modeling, and then we will do exercise. Let's do a little survey here. Would you prefer to do an exercise on agent and acquaintance models before, and then I will go on, and then we will do another exercise, and we'll finish exercises by 3, and then will be time for your presentations. What is your general perception? Just one hour or two sessions for individual work. 1 hour. So everyone happy then? We'll do it as planned originally. Okay, then there will be lunch, and please be back at 1. So otherwise we will be in trouble with time-wise. Many thanks.